This is your second part of your related rates lesson. Okay, let's get started here. An airplane is flying on a flight path that will take it directly over a radar tracking station. If S is decreasing at a rate of 400 miles per hour when S is equal to 10 miles, what is the speed of the plane? Okay, don't dread these word problems. When I do them, I have to read them at least 3 times. One, to just see, okay, I'm talking about a plane and we have a radar station somewhere, and then I read it again to see what I'm really talking about. If you don't have a graphic, you will have to draw this on your own and see if it makes sense. You have a plane flying, and it's flying over a radar tracking station, okay? And since they have the drawing here, they didn't actually tell you that the S is the distance between the plane and the radar station, but that's obvious from the drawing here. And then the horizontal movement, just like the axis, would be X, and this is Y. Y happens to be constant because we're assuming here that, from the drawing, we're not assuming we can see that the plane is flying horizontally, so the Y value does not change, so that's a constant. This S and the X are changing as the plane is moving. So these X and S are values that will change. The 6 will not change. Okay, that's really quite important when you're doing this problem. So, like how I told you to start every problem is, tell yourself what you're trying to find. List that first so you're not lost when you're doing all that math. You can always come back to the top and go, okay, what was I trying to find? Label that first. And from here you can see that so what we're trying to find is, what is the speed of the plane? It's usually the last sentence in the paragraph, what they're trying to find, because the first part of the paragraph tells you what's going on, and the last sentence they'll tell you is, find this. So what is the speed of the plane? So the speed of the plane, as you can see, will be a horizontal movement on X, right? This S does not have anything to do with the plane, so we can say that we're trying to find the change in X with respect to time, because that'll be miles per hour, right? So we're trying to find the change in X over the change in time. State that first. And then the second thing you're going to do is write down all the information that's given to you. What are you given? You're given that S is decreasing at a rate of 400 miles per hour. So this S distance here is getting shorter by 400 miles per hour because the plane is flying towards the station, and this is going to be, this distance here is going to shrink. So since we're talking about velocity, it's going to have a negative sign on it because it's going to the left. You're also given S when S is 10. Okay, remember that S is a changing number, and so is X. But at a certain point, if you froze it, it would be an S. If we did not have any change in time, then this would be an algebra problem, because we're in calculus. Now we have a change in time. That's what the derivative comes from, the dt. All right, so from this we can see that we're dealing with a triangle. So we need a formula for that, and that would be a squared plus b squared is equal to c squared. A right triangle, you know the sides are related by a squared plus b squared equals c squared. We know that this distance is constant, so we'll write that down first. That one doesn't change. Both of these numbers change. I cannot put the s in here. Remember, I told you before that don't write any of the numbers that change into the formulas until the very end. You put numbers in your formulas that don't change at the beginning to clean them up, so make it easier to do your calculus work. So then we can take the derivative of this function here, this triangle here, we can get now dx dt and ds dt. These are the two things that we're trying to find, right? So here is everything that we have. We have pretty much everything that's given. So I'm going to go ahead and take the derivative. The derivative of 36 is 0. The derivative of x squared with respect to t is 2x, and then we have a dx dt, because now we're not taking the derivative with respect to t, with respect to x, which we wouldn't have this term, but we're taking it with respect to t, so we have to have a dx dt equals 2s ds dt, the chain rule for this variable. All right. Okay, now I'm solving for what? Dx dt. Here it is right there. So I'm going to divide both sides by 2x. And the 2's cancel, and I get s over x. And ds dt. All right. Now, we're given s. We're given ds dt. But we have something else we don't know here. X. Is there any way to find x? Yeah, we can come back here. When s is 10, we know what x is, right? If we put all this together, we can solve this for x, which will be x is equal to the square root of s squared minus 36, solving for x here. This would be a plus or minus.
Yeah. Is it recording? Calculus.
Hello.
Hey.
That's so Cassie and David out.
All right, so we have this solve for x, and remember that you take the square root of a square, you get plus and minus, but we're not going to have a negative distance, so we're going to just do the positive. So now if s is 10, we can solve for x, and that will give me 8 miles. So I can put the 8 in here. We have s, we have ds dt, and that will give me a final answer of. So your velocity is negative 500 miles per hour. Okay. So that's how fast it's going to the left. But what question did we ask? They're asking for the speed. What's the difference between speed and velocity? Speed does not have a direction. So the final answer should be 500 miles per hour. You just get rid of that negative because we don't care which direction it's going. We just want to know how fast. Okay, let's have another one here. All right. These problems are challenging, so you may need to take a break, and then come back and look at this. And once you go over it, you might have to go over the last problem again, pause it, look at it. This is one that you're going to see in your homework. You probably see one like this on your AP test. I've seen this one. It is very typical. They might change this up, the shape up a little bit, but you will probably see one just like this. Okay, a trough is 10 feet long, 3 feet wide at the top, and its ends are isosceles triangles. Isosceles meaning that the two sides here are equal length. Okay, we don't know what those are because they just gave us the top. But they do give us an altitude. Altitude is how high it is, so that's the height is 4. Part A, if water is being pumped into the trough at 2 cubic feet per minute, how fast is the water level rising when the depth h is 1 foot? So if you notice that the water is pouring in here, this is forming kind of the same shape here. This shape is a triangular prism, because its faces are triangles and it has a length to it. And then we have this other triangular prism of the water as it's filling up. So they want to know how fast is the water level rising? How fast is this changing when the height is 1. So what are we trying to find here? Trying to find how fast h is changing. We want the rate of change, which is dh dt. Okay. All right. When the depth is 1 foot high. So at this rate, how fast is it changing? If you can see that this is a V shape and you're pouring water at a constant rate, can you see that this fills up really fast? And as it goes up, it's going to take longer and longer to fill. So the height is going to change slower and slower because this volume has to spread out across this whole area. By the time it gets to the top, it will take a long time to fill because this liquid or water that's coming in here has to be spread out across the whole surface area, whereas it was smaller right here, if that makes sense to you. Okay. What information are we given? Well, first, let's identify the variables that change and which are constant, which don't change. This is really, really important because you have to know when you plug in the numbers. Do you plug them in at the end or you plug them in at the beginning? It's always nice to plug them in at the beginning to make things easier so you aren't working with so many variables, but that would be an algebra problem, right? Things change in a calculus problem. So we have variables like the length is L is equal to 10 feet. The base when it's full is 3. Okay, 3 feet. The height when it's full is 4 feet. All right. And the rate at it's being filled is 2 cubic feet per minute. So what is that really? That will be the change in what? That would be a volume. The change in the volume over time is 2 feet cubed per minute. So you see that this is volume over time, right? Volume over time. Everything has to make sense and work. All right, next we have the volume equation of a prism. Volume of a prism is equal to the surface area. Any prism is equal to the surface area times the length. Okay, how much can fit in here depends on how long this is times how much area it is. Think of this as a loaf of bread, right? If you take one slice of bread, well, how many slices of bread will give you the volume of that loaf of bread, if that makes sense, whatever the shape of the face is. Okay, so the volume is equal to the surface area of the face, which is a triangle, 1/2 base times height, and we're going to multiply it by the length, which is L. This is a formula they probably will not give you, so learn to figure out the volume of a prism. All right. So we have this, and now here comes some conceptual things you need to look at. This is a triangular prism of the water that's being filled, and that keeps changing. But you know, by similar triangles, if you take the ratio of the base and the height, should be the same ratio of the base and the height of the little triangle, and it's the same as the big triangle, right? Congruent parts of congruent triangles are congruent. So now we have a proportion. We know that as B increases, H increases at the same rate. So we can make this ratio here. Okay, so now I'm going to fill that in. B when it's full, base when it's full, and the height when it's full is 3/4. So I know that this is going to be 3/4 because I have too many variables in here. That's why I'm doing this. All right, and then I can solve for one of them. And I'm going to solve for B because I'm going to leave H in the working part because I need H when I'm finding it. If I solve this for H, and I would be putting b in here, then everything will come out as b, and I would have to change it again at the end, so I don't want to do that. Okay, so I'm solving it for b because that's what I'm trying to find. I'm trying to find h, right? Now this helps me when I do the substitute to get rid of the b. So I put the 3/4 h in for b, and then I will be able to get rid of the b. I want everything in variables that I'm working with. I'm looking for dh dt, and I have the volume. Now those are only variables I have left because L is the length, is a constant, right? The length doesn't change as I'm filling this, so I can put that number in before I take the derivative. But h changes, so I can't do that now. So simplifying this, I get 30 over 8 or 15 over 4 h squared. H squared, 30, 1 times 3 times 10 is 30, 2 times 4 is 8, reduce that by 2, and then we're going to now take the derivative. We've cleaned this all up. On the left side we got our dv dt, and on the right side we're going to move the 15 over 4 aside while I take the derivative of h squared, and then that will be 2h dh dt. Alright, now after I've taken the derivative, now it wants me to find dh dt when h is 1. Okay, now I can put in that 1 here, and I know that the change in volume over the change in time is 2. That's what this comes from. And this is going to be 1 in a second. I left it like this because we're going to need this part again in part B. So now I put in the 1 here. And, well, let me see. I solved it for dh dt. I multiply both sides by the reciprocal of 15 over 2, which is 4 over 15. The h is supposed to be in the denominator, I just realized, because this is in the numerator, goes with the 15, so the h has to go with the 15. I didn't notice it before because I'm going to plug a 1 in there, and it didn't matter, but this is actually incorrect right here. The h goes in the denominator with the 15, so be 4 over 15h. Then plug in the 1 for the h, and I will get 4 over 15 feet per minute. That's how fast this thing h is going up when the height is 1. Okay, so this keeps changing. This number only works at this height only. Once we get higher up, this will be a smaller number, and when we're below 1 foot, it should be a larger number. Now doing part B. If water is rising at a rate of 3/8 of an inch per minute when the h is 2, when the height is 2, determine the rate at which the water is being pumped into the trough. Okay, what are we trying to find? We're trying to find the rate of change of the water being pumped in, so that will be the change in volume over time. So we can't use that 2 anymore. Okay, we have changed the pipe here. We're using a different flow rate in, so that's changing. That's what we're trying to find. And they give you, this is still the same, the trough is still the same, but they tell you the height now changes at 3 inches per 8 minutes. Now they threw in a wrench here, and kind of a tripping point for some of you. You need to get this from inches to feet because everything else is in feet. There's nothing else in here in inches. So I'm going to multiply that by 1 foot over 12 inches so I can cancel the inches and get feet over minutes now. Okay, 1 foot is equal to 12 inches. Then simplifying this, I get 1 over 32, or reducing the 3 and the 12, I get 4. 4 times 3 is 8. Okay, so now I have the change in height with respect to time is 1 over 32 feet per minute. We're trying to find the change in volume over time, and we have this. And then we're going to, also when the height is 2, I forgot to put that in here. That's also given. Okay, we're going to grab that formula that we had from part A, which I said I was going to use in part B. Now let's just put in all the parts that we know. This is after the derivative. So we're trying to find this, dv dt, and we have the same formula here. We have h, we have dh dt, and we're just going to put that all in. And just doing some simple arithmetic here, we get 15 over 32 feet cubed per minute. Units really, really important on the AP test. Okay? If you weren't keeping track of the units, you would have messed this all up here. You're going to get 12 times the answer. Okay? Be kind of careful. All right. That's it.